All right, we're going to do section 3 today, and it's going to be properties involving functions of more than one argument. Argument here means angle, right? So for taking cosine or sine of more than just one angle. Hopefully you remember, let's do a little review of, do you remember what it means to be an even function? An even function was if you plugged in a negative x into the function, you got the same thing as f of positive x. And an odd function is defined to be that if you plug in a negative x, you get the opposite in sign of that function. And so for trig, we have odd and even functions. Odd and even functions, but now for trig. So which ones fall in there? All right, so what we know is sine of negative x, right? If you look at, here's, if this is x, this would be negative x, right? When you're talking about like a negative angle or whatever. And the sign is negative down here. So this is equal to negative sine of x. And that means that sine is actually an odd function, because when you plug in a negative x, it ends up being a negative sine of x. For cosine of negative x, if this is the positive angle, then a negative angle would be this way, but your cosine is your x value, it's still positive. And so this is equal to cosine of positive x. So this is an even function. For tangent, it's equal to, it's an odd function. It is negative tangent of x. And for me, the way, like, these are the only two I memorize. Sine of a negative angle is equal to negative sine of sine, negative sine. You see that? Sine of a negative angle is negative sine of sine. All right. And then cosine is the positive one. And then tangent, if you remember, tangent of negative x is the same thing as sine of negative x over cosine of negative x, which is a negative sine over positive cosine, which ends up being a negative tangent. So that's how I always remember it. And then the reciprocals are going to be the same. So the reciprocal of sine is cosecant. So cosecant of negative x is negative cosecant of x. Secant of negative x is positive secant of x, since it's the reciprocal of cosine. And then cotangent of negative x is negative cotangent of x. And it's because for all of these, they are the same as the reciprocal. Okay. So we've got odd and even functions. Yes, you should memorize, but listen, I just memorize these two and I can get the rest of them, right? Just memorize those two. And in fact, I memorized that sine of negative x is negative sine of sine. Do you get what I'm saying? It's a negative sine of sine. It's the negative sign. I memorized that one, and then I remember, oh yeah, cosine's not the negative one, right? So, and once you've got those two memorized, then you can get all of the rest, right? Okay, then we've got some more properties. These are called the co-function properties. And that is that sine and cosine are just a phase shift from each other. Hopefully you recognize that, right? I mean, especially when we were doing the graphs of them, and especially when we gave you the graph and you could come up with an equation, most of the time we told you, hey, use the cosine, get a cosine equation, because you can get either a sine or a cosine from any of those graphs because they're just a phase shift from each other. So that's what the cofunction properties are, is that sine of pi over 2 minus x is equal to cosine of x. Yeah. And this would be if it was radians. If it's degrees, so I'll put that, or degrees, would be sine of 90 degrees minus theta is equal to cosine of theta. Yeah. And you can definitely think of just the right triangle, right? Think about, 30, 60, 90-degree triangle, and remember that one was just the other, right? You can think of that to help you remember that if you're asking for sine of 30 degrees, it ended up being the same as cosine of 60 degrees because they're 90 degrees off, Okay. The cofunction property for, I'll come down here, cosine is sine. And again, right, or degrees. And in degrees, it would be cosine of 90 degrees minus theta is equal to sine of theta. So those are the cofunction properties. And the reciprocals of this, okay, so those are those two guys. I guess I should have put that one over there. Oh, well. We've got tangent of pi over 2 minus x is cotangent of x. And cotangent of pi over 2 minus x is tangent of x. These two guys are cofunctions. And it's cosecant and secant who are cofunctions. Think about the graphs of these guys and you'll see why this is true. Cosecant of pi over 2 minus x is secant. And of course, secant of pi over 2 minus x is cosecant. And those are true for degrees also. I'm just not going to write it, but definitely memorize which ones are cofunctions, right? These are all the sine and cosine are cofunctions, tangent and cotangent, cosecant and secant. And it's just that they're a phase shift from each other. All right. So now let's do ones with more than one argument, right? Well, these ones are also, but these are called the composite argument properties. Okay. Cosine of A minus B. So A is an angle, B is an angle. Cosine of subtracting them will be cosine of A times cosine of B. Change the sign. Sine of A, sine of B. So it's the cosine, cosine, sine, sine. Change the sign in the middle. That's the pattern for when it's cosine of two angles. Cosine, cosine, sine, sine. Change the sign in the middle. Since this was a minus sign, it's a plus sign here. Same thing happens if it's A plus B. Cosine, cosine, sine, sine. Change the sign in the middle. So cosine of A times cosine of B. There's a plus sign here, so now it's a minus sign. Sine of A times sine of B. That's the pattern for cosine. Cosine, cosine, sine, sine. Change the sign in the middle. Sine has a different pattern. If you're taking sine of, these are two different angles and you're subtracting them inside there. This makes it's a sine of A, so sine of the first times cosine of the second. Keep the sign, so same sign. Cosine of the first times sine of the second. We call this a sine cosine. Do you see how the sines are the outside like the bread? Like in a sandwich? Sines on the outside, cosines are in the middle. You make a sine, cosine, same sign, sandwich. Right? It's like a sandwich, right? Where the sines are the bread, cosines what's in the middle, whatever your favorite sandwich is, right? And then a same sign in there. So a sine, cosine, same sign, sandwich. All right, so that makes sine of A plus B, same pattern, sine, cosine, same sign, sandwich. sandwich. I want to say sandwich, but then I need to say sandwich to be cute, right? Sine of A times cosine of B, same sign. Boop, boop. Cosine of A times sine of B. Sine, cosine, same sign, sandwich. Okay, now tangent has one too. Now, what tangent is, you could actually put this guy over that guy and then see what happens. But what ends up happening is you kind of have a fake distribute, right? The numerator looks like tangent of, like if you tangent is not something you can distribute, right? I can't. Notice that this is not equal to sine of A plus sine of B. Not true. This is not going to be equal to tangent of A minus tangent of B. It's equal to more than that, but the numerator will look like I have distributed it. Tangent of A minus tangent of B. But then the bottom is going to be a 1. Change the sign. This was a minus sign here, so now it's a plus, and then you'll multiply the two guys together. Tangent of A times tangent of B. Yeah? And that's the pattern. It's like, I call it a fake distribute on top, because it's what you would get if you were to distribute. But then on the bottom, 1, if this is a minus sign up here, change it to a plus sign there, and then multiply them together. All right, so tangent of A plus B, fake distribute, tangent of A plus tangent of B over 1. There's a plus sign here, so this is a minus, and then multiply them together. And yes, you must memorize them all. Memorize. Do-do-do-do-do-be-do-be-do. Okay. All right, let's do some examples. Yeah? All right. Let's show by substituting 60 degrees for A and 90 degrees for B that sine of A plus B is not just distributing sine into both of those, is not equal to sine of A plus sine of B. Because that's what you want to do, right? You see this and you're like, oh, I'll just distribute. Well, it's not. It's equal to a sine, cosine, same sign sandwich instead. Yeah. But let's show it. Let's actually plug some values in, and I'll prove to you that this is not true. So if I plug in 60 degrees for A, what I want to do is show is sine of 60 degrees plus 90 degrees in for B. Is it equal to sine of 60 degrees plus sine of 90 degrees? Yeah, that's what I want to know. Okay, so on the left-hand side, you would want to simplify inside the parentheses first. So 60 plus 90 becomes 150 degrees. And we want to know, is this equal to sine of 60 plus sine of 90? All right, so sine of 150 degrees. Well, where is that? That is, there's 150 degrees. That's a shorty. It's a 30-degree reference angle. So that means this is 1/2. This is rad 3 over 2. Hypotenuse is 1, except that you're in quadrant 2, which gives you a positive y, but a negative x. Yeah? So sine of 150 degrees is 1/2, because it's your y value. Is this equal to, how about sine of 60 degrees? Well, 60 degrees is a tall triangle. So that makes this a rad 3 over 2, this side a 1/2, that a 1. And the sine of 60 degrees, it's the height of your triangle. So that's a rad 3 over 2. And then how about sine of 90 degrees? Well, that's when you use the quadrantal angles. 90 degrees is here. And that point is a 0, 1. And sine, and your r is 1. And so sine is 1 over 1. So your sine is 1. Are those two equivalent? Definitely not. Nope. No question. 1/2 is not equal to rad 3 over 2 plus 1. Not going to happen. And so I've shown you just by plugging in specific values, which is not a proof to show something is true, but you can always use, it's called a counterexample. If you're proving that something is not true, all you have to do is find some specific values to plug in and show that it does not work. So there's your proof. Sine of A plus B is not equal to, you cannot just distribute them to each of them. Instead, you make a sine, cosine, same sign sandwich. And if you were to plug those same values into this, it will work. Yeah. Okay, so let's do that, but let's do it for one of the other formulas. I'm gonna show you by actually plugging in specific values that it works for at least those values. I'm going to demonstrate the given property works for, so obviously this is not a proof that it's true, but we can just show. For when A is 2 pi over 3 and B is pi over 6, and the property I want to show is true for these guys is cosine of the sum of two angles. So cosine of A plus B, remember the cosine formula is cosine, cosine, sine, cosine, cosine, sine, sine, change the sign in the middle. So it's cosine of the first times cosine of the second, change the sign, there's a plus sign here, so now it's a minus sign. Sine of the first times sine of the second. Like that. Okay, so we're going to plug these guys in. And so I've got cosine of plugging in a 2 pi over 3 into A and a pi over 6 into B. And I'm saying, I don't know if it's equal. Well, I do, because we know that that's an identity, but whatever. We're going to show it. Cosine of 2 pi over 3 times cosine of pi over 6 minus sine of 2 pi over 3 times sine of pi over 6. Like that. All right, so you need your values. Well, first of all, we gotta figure out what this is. To get a common denominator, to add them, you need a common denominator, right? So this is 4 pi over 6 plus 1 pi over 6. That would be cosine of 5 pi over 6. And is it equal to that side? Okay, so let's figure out what these angles are. Cosine of 5 pi over 6. That's this guy. That's a 30-degree reference angle, but in quadrant 2. So it's a shorty. 1/2 negative rad 3 over 2, 1. So cosine of it would be negative rad 3 over 2. Is that equal to? All right, now let's figure out cosine of 2 pi over 3. That is 120 degrees. It's this guy. So that's a tall triangle, 60-degree reference angle. So this is a rad 3 over 2 and a 1/2, except that you're in quadrant 2. So it's a negative there. So this would be negative 1/2. Cosine of pi over 6. Here's pi over 6. It's a 30-degree reference angle. So it's a shorty. So 1/2 on that side, rad 3 over 2 on that side, and a 1. So cosine of pi over 6 would be rad 3 over 2. Keep the minus sign. Sine of 2 pi over 3, that was rad 3 over 2. Sine of pi over 6 was 1/2. All right, so let's simplify this left-hand side or right-hand side. That's what, a negative rad 3 over 4, because you remember how you multiply fractions by top times top, bottom times bottom. Negative and a positive makes it a negative. 1 times rad 3, 2 times 2. And then minus rad 3 times 1 over 2 times 2. All right. Well, that makes this side negative 2 rad 3 over 4. And 2 goes into 4 twice. That's a negative rad 3 over 2. Whoop, whoop. All right, we just showed that it was true for these guys. Again, this is not a proof, right? It's not a proof that this is truly an identity. I just showed you for some specific values that it works. I don't think we have you actually prove these this year. I want to say next year in pre-calc, you'll actually prove how this is truly an identity. For now, you're going to memorize it and apply it and use it. Yay. Okay. Oh, I am going to have you prove a cofunction identity. Let's do that. That's good. Okay. Let's prove that this cofunction identity, which says sine of x minus pi over 2 is equal to negative cosine of x. Oh, it's a little bit different from how I wrote it. Yeah. The cofunction identities I gave you said sine of pi over 2 minus x is equal to negative cosine of x, but that's okay. We can do this. All right. I'm going to remember when you're proving an identity, you work on one side. We're going to work only on one side. One side only. Yeah, work on only one side and then get manipulated until you can get it to look like the other side. I definitely think that this left-hand side, once again, is the more complicated side. So that's the side I'm going to start with. I'm going to start with sine of x minus pi over 2. I have an identity. This is x is an angle, pi over 2 is an angle. This is the a minus b. So I make a sine, cosine, same sign, sandwich. Yeah? Sine of the first times cosine of the second. Same sign. Cosine of the first, sine of the second. I'm using the sum, the composite angle identity there. The sine, cosine, same sign, sandwich. Sine's on the outside, cosine's in the middle, same sign. Okay, how does that help me? Well, I don't know what sine of x is, but I do know what the values of cosine and sine of pi over 2. Pi over 2 is a 90-degree angle. Here's pi over 2, and your cosine is 0 and your sine is 1. Since your r is 1, yeah. So that means I've got sine of x times cosine of pi over 2 is 0 minus cosine of x times sine of pi over 2 is 1. 0 minus cosine of x is negative cosine of x. And I have just proven the right-hand side. Yay! Gotta love it, right? Okay. All right. Okay. Are you ready for a more complicated one? You are forewarned. It's a challenge one. Okay. If sine of angle A is 1/2 and cosine of angle A is greater than 0, that means it's positive. If tangent of B is 3/4 and sine of angle B is negative, less than 0. That means it's negative. Let's do that. This means it's positive. This means it's negative, right? Less than 0 means negative. Greater than 0 means positive. We're going to find tangent of A plus B. All right. So keep in mind when we're asking you for this, that's that formula, right? That's that identity that has the fake distribute up top. So what you need is you need tangent of A and tangent of B. Well, I've got tangent of B. All right, that's nice. But I do need tangent of A. And so let's do this. This is okay, whatever. All right, so I'm going to draw out this guy. If sine of A is 1/2 and cosine is positive, so sine's positive and cosine's positive, that means angle A is a quadrant 1 angle because sine is positive and cosine's positive, right? The fact that sine of A, they tell us sine of A is 1/2, right? Well, that means that's y over r. So 1, 2. Yeah. Well, using Pythagorean theorem, it's your x squared plus 1 squared equals 2 squared, which means x will be plus or minus rad 3. And then which one do you choose? Because I went 4, subtracting 1, you get a 3, taking the square root. But you choose the positive because I'm in quadrant 1. So this is rad 3, like that. So what does that mean? That means, well, I'm going to help you find this stuff because different problems ask you for different things, right? So cosine of A will be x over r, so that's rad 3 over 2. Tangent of A is y over x, so 1 over rad 3, which, we rationalize and say rad 3 over 3. Okay, I know they already gave me tangent of B, but I'm going to go ahead and draw the triangle because if they wouldn't have asked us for tangent, you might have needed to find sine or cosine. Okay, so let's do the same thing for angle B. Your tangent is positive. Your sine is negative. Do you see that? Okay, so sine is negative. Remember, tangent is sine over cosine, right? And they tell us sine is negative, and then over something is equal to a positive number. So the only way for you to have a positive tangent when sine is negative is for cosine to be negative also. So that means your y is negative, your x is negative. So this is a quadrant 3 angle. Yeah. There you go. Tangent is y over x. So this is a 3 and a 4, but they're both negative since they're in quadrant 3. And then your hypotenuse, you could do Pythagorean theorem. It's a 5, right? So just in case, there will be some of your homework problems where you'll need to find, okay, what's sine of B? That would be y over r, so negative 3 over 5. What's cosine of B? That's x over r, so negative 4 over 5. And then, of course, tangent of B. They did give us, it's also sine over cosine, a negative 3/5 over negative 4/5. The 5's cancel, the minus signs cancel. You end up with 3 over 4. Okay. So again, for this problem, you didn't have to find this information, but I guarantee you, you will have problems either on the test or on the homework where you actually had to go and find information more than what was just given to you. So that's how you do it. All right, so now I can, now that I know these values, I can find tangent of A plus B. And the identity says the top is a fake distribute. Pretend like you're distributing, but that's not the end of it. Over 1, if this is a plus sign, then there's a minus, and then multiply them together. Tangent of A times tangent of B. All right, so I can plug these things in. Yes? All right. Tangent of A, we said was rad 3 over 3, plus tangent of B is 3 over 4. 1 minus tangent of A times tangent of B. Okay, so now we got to clean this crap up, this stuff up, right? In order to add these two guys together, you need a common denominator. So I would have needed to multiply by 4 over 4 and this one by 3 over 3 so that my numerator becomes a 4 rad 3 plus 9 over 12. That was just the numerator. Yeah. 4 rad 3 plus 3 times 3 is 9 over 12. Bottom will become okay, well, this would be a 3 rad 3 over 12, but it's a 1 minus, so I would go 12 over 12 minus rad 3 rad 3 over 12. So this becomes a 12 minus 3 rad 3 over 12. Yeah? Okay. You could go and multiply by the reciprocal at this point, but I'm not going to. I'm going to use the trick that if you went and multiplied by the reciprocal, these two denominators are going to cancel. They're the same, right? If they're not the same, you got to multiply by the reciprocal, but they are exactly the same. And so you will end up with a 4 rad 3 plus 9 over 12 minus 3 rad 3. Can you stop? No, because you got a radical in the denominator, so you got to multiply top and bottom by the conjugate of the denominator. So I'm going to multiply top and bottom by 12 plus 3 rad 3. All right, so that I get, I'll come down here. Do FOIL it out. 4 rad 3 times 12 gives you a 48 rad 3. So just multiply the 4 and the 12. So 48 rad 3. Outer and outer would be a 4 times 3 times rad 3 times rad 3. So how about if I do it's 12 times 3 because it's the 4 times the 3 and then times rad 3 and rad 3. So that was first times first, outer and outer. Inner and inner is 12 and 9 multiplied together is a 108. And then 9 times 3 rad 3 will be 27 rad 3. Okay. Bottom, you just multiplied conjugates, right? So you can FOIL it out, but the middle guys are going to cancel, and you'll end up with first one squared minus last one squared. Yeah. All right, so this bottom just ends up being a 144 minus 27. Yeah. Okay, so then I've got, you can combine like terms, 48 apples and 27 apples. Yeah, so that's what, 75 rad 3? And then 36 plus 108 will give you 144. 144 minus 27 gives you 117. Can you stop there? Well, no, because there is something in common. You should definitely reduce if you can. And what I notice is there's a 3 in common to all of these guys. If I factor out a 3, I would be left with a 25 rad 3 plus 3 times 48 will give me 144. And then 117 is 3 times 39. So those 3's cancel. And your final answer is 25 rad 3 plus 48 over 39. Oof. Okay. That's probably the most complicated it gets. Yeah, that was pretty crazy. But all right. I hope you all are having a fantabulous day. Bye.